Now in the second video we're going to talk about asymptote. We took it in secondary 2. Limit at infinity. First of all, for horizontal asymptote we have three categories. If degree ax smaller than denominator, degree below is bigger, so remains x down, so it's 0. If degree up equal degree below, you're going to have a over b, y equal a over b, horizontal asymptote. And if degree ax bigger than bx, so it's infinity, so we have oblique asymptote if the difference is only 1 between the degrees. Let us take examples so that you will refresh your memory. If you want to do limit as x tends to plus or minus infinity of 2x plus 5 over 3x minus 2, you can do it directly. You can do this process a number over infinity 0, so 2x over 3x over 3, or you can say directly it's 2x over 3x because I have infinity, so 2 over 3. So y equal 2 over 3 is horizontal asymptote. So here we have degree above equal degree below, so we have y equal a over b, horizontal asymptote. Here same story, here x squared and x squared, so it will be 1 over 5, horizontal asymptote. Here degree below is bigger, so it must be 0. So here it's going to get x over 2x squared 1 over 2x, a number over infinity 0. So always if degree below is bigger, you have y equals 0, horizontal asymptote. And if degree above is bigger, you have plus or minus infinity, you have oblique asymptote. So how to find the oblique asymptote? You do the ordinary division. So the quotient here that you have will be the oblique asymptote. You know these from last year, just to refresh your memory. Here find the vertical and horizontal asymptote of this function. So first of all, you all know denominator cannot be 0, so x cannot be 3, so everything except the 3. So the 3, because it makes the denominator 0, it's vertical asymptote. So we start the limit first of all at plus or minus infinity. At plus or minus infinity, so x over 2x is half, so y equal half, horizontal asymptote. Now you want to do it at 3. You all know a number over 0, because if you replace by 3, it's 1. You have 3 from the 3 minus or 3 plus. If you put 3, it will be 6 minus 6, 0. To know if it's 0 minus or 0 plus, a value of 3 minus, for example, it can be 2.9. 2 times 2.9 is 5.8, minus 6 it's negative, so minus infinity. And if you do it in 3 plus, the same story, 3.1 times 2 minus 6, it's 0 plus, so plus infinity. So here we have one horizontal asymptote and one vertical asymptote. So here in that case, if you want to graph at this asymptote, you have y equal half horizontal and you have x equal to 3 vertical. Hala. At 3 minus, before 3, this is 3 minus from that side, it must go down. Okay, and you have this is horizontal asymptote at minus infinity, as you can see, and at the 3 plus you have coming from up and going to y equal half, horizontal asymptote, because 3 plus is plus infinity. So if you do now 2x plus 4 over x squared minus 4, so you have two impossible values, so I have two vertical asymptote here. Okay, so if you do first of all limit at plus or minus infinity 2x over x squared, a number over infinity 0, you have horizontal asymptote. At 2, you know 4 plus 2 6 over 0. If you take 2 minus in a 1.999 and you square it, minus 4 it's negative, so minus infinity, and 2 plus it will be 0 plus, so you have x equal to 2 vertical, and same for minus 2 minus. Minus 2 minus, you take minus 2.1, you replace it, you have one horizontal asymptote here and two vertical asymptote. Here degree above equal below, we have second degree, so you have no roots because you don't have roots, so no vertical asymptote. And if you do a limit as x tends to, so x belong to R, we don't have vertical, we do horizontal asymptote, limit as x tends to plus or minus infinity, it will be 2x squared over x squared, which is 2, so only we have horizontal asymptote, we don't have vertical asymptote. Why? Because we don't have value that make denominator 0. In number 4, degree above is bigger, so we have oblique asymptote. Always when degree above is bigger and differs by 1, we have what's called oblique asymptote. So here x cannot be 3. This is a vertical asymptote. We do first of all limit at infinity. So x squared over x, so x plus or minus infinity. If you do the division, you can check it by yourself. You have x plus 1 oblique asymptote. Concerning, and this f of x, we're going to need it for in other videos, can be written as x plus, instead of writing it of that sort, we may use to write it of that form because it will help us in many parts of problems. So you can write it as x plus 1 plus remainder 6 over divisor, which is x minus 3. And if you do limit at 3 minus, the same thing, 3 minus a number over 0 plus or minus infinity, but 3 minus, if you put 2.9, so it will be 0 minus minus infinity, and if you do 3 plus, it will be 0 plus plus infinity, which is a vertical asymptote. Now we're going to talk about things also you took it last year, relative position of two functions. So if they ask you what is the relative position between two functions, you just need to do f of x minus g of x and do its table of sign. If f of x minus g of x is positive, you say f of x above g of x. If it's less than 0, you say f of x below g of x. And if it's equal to 0, it means they intersect. Okay, we're going to see it in the coming problems. I'm going to have the questions about relative position. And center of symmetry, you took it last year. To prove that a point is a center of symmetry, you need to show the point whose coordinates are a and b, that f of 2a minus x plus f of x equal to b. Come in, we're going to do problems related to that sort. Let us start to refresh your memory. Find the domain of the following function, then deduce the asymptotes and draw the table of variation, then graph. You have this one. This is an ordinary parabola. X cannot be minus 2. You do limit at infinity 2x over x is 2. So y equal to horizontal asymptote, and x cannot be minus 2. If you do minus 2 minus minus 2 plus, you have this answer. Now if you have problems in putting plus infinity minus infinity, you can deduce it from table of variation. You're going to see how. If you do the derivative, this is of the form u over v. U prime is 2 times x plus 2 minus derivative of x plus 2 is 1 times 2x minus 1 over denominator square. So the answer, as you can see, 5 over x plus 2 square is always positive. So how do we write the table of variation? You have x, f prime of x, f of x. You have from minus infinity till infinity. You have the impossible at minus 2. So we do this hash here, because to say it's a vertical asymptote, it's always f prime is positive. So plus, plus. So increasing. Derivative is positive, it means increasing and increasing. As you can see here from minus 2, from the other side minus, it's going up. So plus infinity. So that's what I meant. If you don't, you're not sure about it, you can check it here. And from minus 2 plus, it's coming from down. The curve is coming from down. So it's minus infinity. And you have at minus infinity and plus infinity, as you can see here, y equal to 2 horizontal asymptote. So you put y equal to 2 horizontal asymptote. You have x equal minus 2 vertical asymptote. This is the original axis. So you have it from y equal to 2 up till x equal minus 2, like this one. Y equal to 2 and x equal minus 2. You can see it here. Y equal to 2 horizontal, it's that 4. And going to x equal minus 2, so you have that shape. And here from down, this is the vertical asymptote. From the vertical asymptote to y equal to 2, so it has that shape. You can see it here. You can take particular points more to be sure. A point after minus 2, it can be 0, so it must pass by 0 minus half. You can see the minus half here. Now the question, show that the intersection of the asymptote is a center of symmetry to f of x. So how many asymptotes here I have? I have x equal minus 2 and y equal to 2. So they intersect these two at the point A here. You can see x is minus 2, 2. To prove that this is a center of symmetry, you need to show the formula f of 2a minus x plus f of x equal to b, where a is minus 2 and b is 2. So you just replace a is minus 2. You need to show that f of minus 4 minus x plus f of x equal to b, which is 4. So we start. F of minus 4 minus x, so you go to f of x, you replace these two x's by the new one, minus 4 minus x. So you're going to get 2 into minus 4 minus x, close parenthesis, minus 1, over minus 4 minus x, close parenthesis, plus 2, plus f of x as it is. So if you continue, you can see these two are opposite. You can, for example, you can put minus before, okay, and then put this minus up, it will be 9 plus 2x. Then you have x plus 2, same denominator, you add it to 2x minus 1. You're going to get 4x plus 8 over x plus 2. You can put 4 in factor. So it's equal to 4, what I want to show. So in that case, I have proved that f of 2a minus x plus f of x equal to 4. So the intersection of the asymptote is a center of symmetry. Another example. Here you have x squared minus 3x plus 2 equal to 0. You have two roots, and it means I have two vertical asymptote 1 and 2. If you do limit at infinity, it's x squared over x squared, so y equal to 1 horizontal. You have here the 2 minus, you have the 2 plus, and we must have the 1, the limit at 1. I didn't do it by mistake. You need to do limit as x tends to 1 minus, if you do it, of f of x, you're going to get 1 plus 1, 2. And if you put 1 minus, it means 0.999. You're going to get 0 plus. You can check it by yourself. It will be plus infinity. And I have deduced it from the table of variation that I have it here. I have 1 minus, it must be plus infinity. 1 plus, it must be minus infinity. So now, same for x equal to 1, where x equal to 1, vertical asymptote. You can do it by yourself. I have wrote this sentence, I didn't realize it. So f prime of x, u prime v, so 2x into x squared minus 3x minus 1, minus derivative of x squared minus 3x plus 2 is 2x minus 3 into x squared plus 1 over denominator squared. Now you did f prime of x, we did. Always before we had 5. 5, you cannot equate this to 0 because I don't have x. Because every time derivative equal to 0, you're searching for maximum or minimum. So we take the numerator, you equate it to 0. Using calculator, you have two roots. So now we do x, f prime of x. First of all, I have impossible at 1 and 2. You can see here 1 and 2. And I have the two roots which are max or min, 1.39 and minus 0.72. I have the two roots. Now it's an equation of second degree, same sign as a, opposite sign of a, same sign as a. A is minus, so we start minus. Then reaching the 0 plus plus, then after 0 minus minus. If you have a mistake here, you're not sure, take any number before minus 0.72. Take minus 1 and replace it in f prime of x. If you take minus 1, it's going to get minus 3, minus 2, minus 5. Plus 3 is negative. Any number between minus 0.72 and 1.39, you can take 0. It's positive plus 3. And between 1.39 till infinity, you can take any number which is 3. 2 is impossible, you cannot take it. So you can check that this is minus. Minus going down, plus going up, plus up, minus down, minus down. At plus or minus infinity, we have horizontal asymptote from here, which is y equal to 1. And then you replace here, you have f, not f prime. You replace minus 0.72 here, and 1.39, you have these two values. At 1 going up, it means plus infinity, 1 minus, 1 plus minus infinity, 2 minus is minus infinity, already we have it, we did it, and 2 plus is plus infinity. So if you want to graph, what I want you to do, you have y equal, it's very easy from here without graphing. Y equal to 1 horizontal, going to this minimum, and then going x equal to 1. Then coming from x equal to 1 to the maximum, and you have here another vertical, x equal to 2. It's very simple, you can see it here. And then coming from y equal to 2 to y equal to 1. So if you want to graph it, suppose I don't want to put the x and y axis, not to do a mistake, you have here, this is y equal to 1. It has that form. It's coming from y equal to 1. You have a minimum somewhere. Then going to the vertical. Then between the two vertical asymptote, you have like this one. And then between here, you have coming up. Then going to y equal to 1. You can see it here. This is of that form. But the particular points here, it will make you will be sure how to graph it. This is what. This is the first. Here you have minus 0.72. This is the minimum. The first minimum, and here you have here the first, the second maximum, and you have here the two vertical and the horizontal. And suppose the question now, okay, write the equation of the tangent at x of a equal to 0. Equation of tangent is, you took it last year also, y minus ya equal y prime of a into x minus x of a, and I gave you x of a. If you replace x of a by 0, you have half. You want f prime of half. If you replace it here, it will be 3 over 4. You just replace here y of a by half, y prime of a by 3 over 4, and x of a is 0. So you get the equation of tangent. Another example. Here, if you want to do the limit at infinity x squared, or we don't have values that make denominator is 0 because down is always positive. It cannot be 0. So you have y equal to 1 horizontal. If you do the derivative, you have this one. You equate it to 0 using calculator. You have these 2 points. I don't have vertical asymptote. So same sign as a, opposite sign, same sign. This is 2 plus minus plus, or you can take values and replace it in f prime. You can take minus 3. If you replace it, it will be positive. You can take, for example, 0 here. It is negative. You can take then 1 after 0.41, replace it in f prime positive. Up, down, up. For these two, you can replace it where here. And plus or minus infinity, y equal to 1. So if you want to graph it without putting the x and y axis, you have y equal to 1. Okay. From y equal to 1, you can go to a max. This is the maximum first of all. Then you go to a min here. Then you go to y equal to 1. This is what we did. You can take more particular points. Another example. Now we started by the main important thing where the degree above is bigger. So first of all, x plus 2 not equal to 0, x equal minus 2. This is a vertical asymptote. If you do the limit at infinity, it's a plus or minus infinity, you have oblique asymptote. To do the oblique asymptote, you must do the division. So it will be y equal to x. But I advise you always y equal to x. So write it as x plus 1 over x plus 2, because we may use this one in many questions. So if you do f prime of x, so 2x plus 2 into x plus 2 minus 1 into this one over x plus 2 square, you have this answer. If you equate it to 0, you have minus 1 and minus 3. So minus 1 and minus 3 here, as you can see, and the minus 2 is impossible, which is a vertical asymptote. The equation of second degree, same sign, opposite sign, same sign, so plus, minus, minus, plus. Or you can take values in each quadrant and replace it in f prime to know if it's positive, negative. Up, down, down, up. It means minus 2 minus, it must be minus infinity. You can see it here. Minus 2 plus coming from up, plus infinity. If you replace here by minus 3, you have minus 4. If you replace by minus 1 here, you have 0. And here you have at plus or minus infinity, you have y equal x oblique asymptote. So how we're going to graph this one? We put x equal minus 2, and this is the oblique asymptote by y equal x. 0, 0, 1, 1. Y equal to x. If you take two particular points, if you replace x and y, 0. If x is 0, y is 0. If x is 1, y is 1. So we graph these two. So I have maximum between minus 3, this is minus 4. And you have minus 1 and 0. So it must be coming from the horizontal asymptote, going to a maximum to x equal minus 2, you can see it here. Then coming from up to this point, which is minimum, we have it here, the point A, and going to the horizontal asymptote, as you can see. Now, always they ask in this question, and in this year, to prove that we have oblique, show that y equal to x is an oblique asymptote. Always, if you want to prove that you have an oblique asymptote, there is only one way, no other way. You must show that the limit as x tends to plus or minus infinity of the function minus its oblique asymptote, it must be 0. If you show that f of x minus its oblique asymptote, the limit is 0, you have proved that we have an oblique asymptote. So if you do it, you can use this one. Minus x, you must do same denominator, whatever. You have a number over infinity, 0, what I want to show. So that's why I told you better to write it that form, not to do same denominator and do mistake. F of x can be written as x plus 1 over x plus 2 minus the oblique asymptote here is x. So x and x cancel. So directly you have 1 over x plus 2, which is 0. So always in the question, to show that you have an asymptote oblique, you must show that limit as x tends to plus or minus infinity of f of x minus the oblique asymptote, you must get the answer to be 0. If you have the answer equal to 0, you have shown that y equal, for example, whatever is an oblique asymptote. Show that the intersection of the asymptote is a center of symmetry. So here I have two asymptotes, y equal to x and x equal minus 2. If you replace y equal x and x equal minus 2, you're going to get, if x is minus 2 and y equal to x, so you're going to get the point minus 2 minus 2. So you need to show that the point minus 2 is, if x is minus 2, okay, is an oblique, is a center of symmetry. This is minus 2, sorry, I have wrote it as 2. So you must show that f of 2a minus x plus f of x must be equal to b, where a is minus 2 and x is also minus 2. So it must be f of 4 minus x plus f of x must be equal minus 4. So for that reason, you replace. I want to use this one. This one is better. Instead of x, I want to write minus 4 minus x, and here instead of this x, I will write also minus 4 minus x plus this, that's it here, plus f of x as it is. You can see x and minus x cancel out. Here always these two cancel out. Why these two cancel out? Because minus 4 minus x plus 2, you're going to get minus 2 minus x. Always it's the opposite. And what is left here? It's left is minus 4. So we have proved that it's center of symmetry. So what I was saying here, if you do if you do this one, you're going to get 1 over minus 2 minus x, and here 1 over x plus 2. These are opposite. Why? You can put here minus in factor, okay, here it will be plus, and this minus you can put it where? Up. So minus 1 plus 1 is 0. So I'm left with this number, which is minus 4 equal minus 4. So we have proved that we have study relative position that I talked about. To study relative position between f of x and its oblique asymptote, I want to find the sign of f of x minus oblique asymptote. So that's why always when you have rational where degree above is bigger, better to write it of that form. Why? Because if I write f of x minus its oblique asymptote, which is x, these two cancel out. I'm left with 1 over x plus 2. Okay, like I did in to prove oblique asymptote, but I use in oblique asymptote limit. So if you do this one, you have 1 over x plus 2. The root here is minus 2, which is impossible. So if you take a number before minus 2, which is minus 3, if you replace it here, it will be negative. A number bigger than minus 2, which is 0, it will be positive. So f of x minus oblique asymptote less than 0 if x less than minus 2. So it means f of x less than oblique asymptote if x less than minus 2. F of x is above oblique asymptote if x bigger than 2. Okay, plus f of x is above minus f of x below. Write the equation of tangent at x equal to 1. You need to find f of 1 and f prime of 1. F of 1 here 4 over 3. F prime of 1, if you do it here, it will be 8 over 9. So you replace it and you get the answer. More problem of that sort of problems. So here you can check it by yourself. The graph here you have, if you do the derivative, 1 minute. If you do it, you don't have max or min, only you have 1. Either all is positive or negative. Because a is minus, so it's minus. Or you can take a value less than 1 or bigger than 1. You can check, it's always negative. Here you have the graph, you can check it by yourself. Show that the intersection of asymptote is a center. Here I have two asymptote, y equal minus x plus 2 and y equal to 1. If you replace x by 1 here, you're going to get 1, 1. You need to show that f of 2a minus x plus f of x equal to b. better to use this one. You can check it by yourself. Relative position, also the same thing. You want to find f of x minus the oblique asymptote. You have 3 over x minus 1 like we did. Here it's below, here it's above. Okay, and if they ask about show that you have oblique asymptote, you need to show that limit as x tends to plus or minus infinity of f of x minus oblique asymptote must be f of x minus oblique asymptote must be 0. So which one is better to use? Better to use this one, because the oblique asymptote is this one. These two cancel out. What remains? 3 over x plus 1. A number over infinity is 0. I have proved that we have oblique asymptote. Okay. Here another problem. Okay. But here the problem, I want to start from 2 till infinity. So I cannot put from minus infinity from now and on. So if you do the division, because you have above is bigger, you have y can be written as 2x plus 2 plus 5 over x minus 2. We do limit at infinity, so it's 2x infinity, you have oblique, and you do, and we want to show that the existence of oblique asymptote, as we said, f of x minus oblique asymptote remains this one, a number over infinity 0. I want to do limit as x tends to 2 plus, I don't have to minus. Okay, it's plus infinity. You do the derivative, you have two values from calculator. Minus 2.8 is rejected because it's not in the domain. You have only 3.58 from 2 till infinity because this is the domain given. So if you take a number before 3.58, you can take, for example, 0. If you replace it in f prime of x, this is f prime of x. Okay, not before, between 2 and 3.58, sorry. You can take, for example, you can take 0.3. If you replace 3 here, 18 plus 3, 21 minus 24 negative. If you take a number bigger than 3.58, you can take 4, it will be positive. Well, f of x you replace by 3.58 here, you get this number. So down and up, you have x equal to 2 vertical, coming from the vertical to the minimum and to the oblique asymptote, which is graphed here. Show that the intersection of the asymptote center of symmetry, you can check it by yourself, because here if you replace x by 2 you're going to get 6. You can check it by yourself, guys. Something easy. Relative position, same story. Equation of tangent, same story. Here I have it from -3 closed. What does it mean, the difference between this one and that one? Here it's open. It means it's in the denominator 0. It's impossible. Here it's closed. It means closed. I don't do limit. The point is accepted. The impossible is -1 only. So I do f of -3, not more. F of -3. Okay, because it is closed. Here there is something wrong. I want to erase it. I don't have minus infinity, guys. There is a point. So if you do f of -3, what do I get? -7 plus 3, because I do sometime copy paste of the problem above. I didn't change this one. So -3 plus 2 plus 1 is -2. So you're going to get -8.5. So here you must start by -8.5, not by oblique asymptote, because the point is accepted. So we do limit at infinity first of all. So a number over infinity 0 remains infinity. Okay, so we don't do at minus, we do only plus because I don't have minus. For concerning -1, I do -1 minus and -1 plus. You can check it. We do the derivative. A prime of x equal to 0 at the point -2.22 and 0.22 from calculator. These two are accepted because they are from -3 till infinity. So -1 is impossible. For example, for table of sign, you can take a point before -2.22. You replace it in f prime, or same sign. A is positive, plus, minus, minus, plus, up, down, down, up. So here you replace in f of x -2.22 and 0.22. You have these points, and you graph it that form. It starts from this point. Here you have a point, start, max, and then y equal -1. Then here from -1, the 1.9, and going to the oblique, asymptote, as you can see it here. Show that the intersection is the center of symmetry. You can check it by yourself, the same. Relative position also the same. Another problem is this form. Here it's open, it means denominator is 0. You must do a limit, as you can see. First of all, limit at infinity. A number over infinity 0, you have minus infinity, and no need to do the division because already the oblique asymptote is minus 3x minus 1. And to prove it, you do it f of x minus oblique remains 3 over minus 2x plus 1, which is 0. And limit as x tends to 0.5. Here minus 2.5, here 0 minus, if you check minus infinity. You do the derivative, you have two values. Minus 0.21 is rejected because it's not in the domain, and you have 1.21 which is accepted. You have half, which is a vertical, minus plus, you take a point before 1.21, you check it's negative. You can take, for example, 1.5. Okay, sorry, not 1.5, you can take 1. Okay, if you put 1 in f prime, minus 12 plus 12 cancel, you're going to get 3 here in f prime of x. Let me see if we have something wrong. So minus 12x squared plus 12x plus 3. So here I have something wrong. If you put 1, it will be 3. It must be positive. Here is negative, but these are correct. Plus going up, negative going down. So you have here vertical, here oblique asymptote. It must be between vertical and you have one oblique. It must be that form where you have it here. Show that the intersection of the asymptote is the center of symmetry. You can check it. Relative position, you start from half till infinity because domain is half till infinity. So here, if you take any value after half, for example, you can take 1. You can see it's minus, so as you can see, the curve is always below. This is the oblique asymptote, and this is the curve. The curve is always below the oblique asymptote. So that's it for the second video. This is a recall of things you covered all last year. I don't have anything you didn't cover last year. Okay.